After looking at the traditional way of data processing, which is ETL, let's take a look at how data are loaded into data lake. By definition, data lake contains all the files, right? All data lake contain files, and these files are generated by the transactional system. So data lake, by definition, is a collection of raw data. That means in the paradigm of design in a data lake loading process is very different from the data warehouse world. In a data warehouse world, the data warehouse is the end target state of loading. And the files coming from the source systems are just intermediate results that can be and should be removed right every time after you process it. But in the data lake world, the paradigm is different. Data lake will store the raw data as its main data feed. So data lake and the files in that are not are the target state already, not the intermediate result. For this reason, all raw data will be saved in data lake. That's why we have, instead of ETL, we have ELT, the concept of ELT. After we extract the data, we will load it before we're doing any transformation. All data, raw data should be saved into the data lake. And for this reason, if the raw data is already there, we may not need to process that. Even if the file is there, we will only process the files when it's necessary, when we want to read the data. That's the time we will do the process. That's why we have this ELT instead of ETL. We will extract first, we will load it. Once the raw data are loaded, then we do the transformation. So this is the term ELT comes from. Here, extract, load, transformation. They are the same words as in ETL, just that the order is different due to the fact that in the data lake, data file is something that we will keep. So we will load and keep. Instead, transformation will comes only after those files are loaded. However, there is a challenge with this approach, which is not all data sets are equal, right? Some still requires more attention. Raw data by itself contains all the information, but if you need to read from these data every time, then it will give you some issues, some performance issue. You still want to somehow transfer them, moving them into a higher level of data extraction, data transformation. But then the problem comes in. If everybody is using a file, if all the intermediate results are files, how do you determine which file you should keep? Because if you save, because if after each transformation you save it to a file, quickly your data lake will be swamped with the intermediate results. There's no clear definition of what files are in here, and organizing them will be a nightmare. For this reason, we have this what we call a Mendelian architecture, which is a guideline for designing the data lake, the storage the layers. So the Mendelian data architect comes from, as you can see, it's built on top of a Delta Lake, which comes from Databricks. But this is applicable to all data lake houses, not only Databricks. The Mendelian data architecture organizes the data in a data lake through three different layers: bronze layer, silver layer, and gold layer. And the bronze layer is just raw data, all as is. And the current day plus some metadata, like if you have a file, which date, during which day was this loaded, which process loaded it. So it's a raw data, as simple as that. Raw data plus its metadata. The current practice is to collect the data as detailed as possible, as much as possible, because at this point, storage is cheap, especially with a cloud architecting archive layer, cloud storage archive layer. Storage is really cheap. So the current practice is to collect them as detailed as possible and as much as possible. Then we get to a silver layer. The idea of silver layer is to create a conforming database, the data sets. Um, the reason we say talk about conforming is first of all, it has to be cleansed, right? And it has to be filtered and it has to be joinable. So the idea is silver layer is between gold layer and the bronze layer. Um, Silver layer is about transformation, but we need to have a clear definition of the state that transformation will get to. So what's the minimum required state of a data in the data lake? The answer is it has to be clean. It has to be it has to be capable of being utilized across the whole enterprise. And the first one means you will need to perform certain cleansing and filtering, like collecting typos, handling missing values, removing inconsistent values, removing unnecessary data. This is clean about clean of a cleanness. Then you need to transform it so that it's available to the whole enterprise, which means there has to be some kind of enterprise level identity and data format that can be utilized. We mentioned about like months and date format, right? If a corporate has all the data months format flying around, the US format, which has a month first, date followed by date, and the UK format where you have the date first, then followed by months. You have these two data mixed together in the same data set. It will be a nightmare. There has to be a corporate standard on the data lake silver layer, on the data lake, that what this corporate format has to be. All date values in this corporate has to be following this format. And the silver's architecture, silver layer, serves as the place where all these are extracted and deposited into silver layer, into the data lake silver layer, following the standard. And also, if you have, we talked about conforming ID. If a person, the same person, has ID of ABC in source system A and ID 123 in source system B, there got to be an enterprise-wise ID that matches to these systems ABC and 123. As soon as you see this enterprise ID, you can link this ID to the real person. And similarly, this is similar for any other entities that has the multiple data sources that show up in multiple data sources, right? So this is about cleansed and conformed. And you may also want to do some like normalization and denormalization if the source data, raw data, is from JSON or some semi-structured data. So outside of these, once you finish these steps, and there are still something you can do. But after you finish these 4 steps, cleanse, filter, conform, normalize, and denormalize, you pretty much have a silver layer in which the data are clean and available readily for the whole enterprise to be used. You can add some other feature engineerings. You can add some other processings. But then the question comes, do you want to join? Do you want to do aggregation? It's a matter of preference, but in general, the idea is you should not. You should hold on until there is a clear reason of doing that. Because the idea of a data lake of an ELT is you want to load and transform. Transform only should happen when there is a need. So for silver layer, you should only do the minimum required work, which is cleansing, filtering, conforming, and normalizing, and some necessary feature engineerings. But of course, it all depends on your situation. If in your situation you do need to do some transformation, then go ahead and do that. And just make sure that you are maintaining a standard on what should be done, what should not be done, so that you have consistency in deciding the data set quality. And finally, we have a gold layer, right? Gold layer is comes from the silver layer and is ready for reporting. It's actually the same as the data mart that we have been talking about. It's denormalized into star. It's normalized into star schema, aggregated into statistics. You can use join to combine data from different data sets, and it's consumption ready and project specific. So once again, this is the Medallion architecture. You have a bronze layer, starting with a bronze layer, which have a raw data and their metadata. And then some ELT tool will perform a transformation to move the raw data from bronze layer and cleanse them, filter them, perform the conforming task and denormalize, etc. And put this into the minimum available state of cleansed and enterprise-ready data. Then you do some further transformations, moving from this enterprise-ready data from silver layer into gold layer, forming a business level reporting ready, consumption ready data set, ready for the usage of machine learning and business intelligence. So comparing the Medallion architecture versus the traditional staging approach, Medallion architecture and the staging approach are not exclusive. Staging approach is still a very important part of the data warehouse ETL design. So when we talk about ELT, this is the general ELT and the data lakehouse. This is the generalized approach. But that does not mean that data warehouse is not important. But instead, data warehouse is an important part of the lakehouse. So for data warehouse loading, if the data lake warehouse is inside the lakehouse, you will still following a similar approach. Just that this time, you may not need the staging. You can directly read from silver, but conceptually, the silver layer is also a part of staging. And then you can have your own staging if you need to form some calculation, perform some transformations of the data. If you still need to certain transformation that only doable inside a relational database, then that's where you need to have your staging table. So very likely, when you find a job, you will see a mixture of both. You will both see the silver layer and you will see the staging area. And one note is also that we mentioned that this Medallion architecture was invented by Databricks. Interestingly, Microsoft recently, as they announced the new product the suite, the Microsoft Fabric, they actually utilizing this Medallion architecture. They put this in their official documentation for data lake design, which means Microsoft now stands behind this Medallion architecture concept. Of course, it's utilized for the Microsoft Fabric, which is new product, but the basic design concept of Fabric is based on the Synapse analytics. So the same concept of building this Medallion architecture is also applicable to Synapse Data Lake. So either way, Medallion architecture is an important part of data lake design, and we will also utilize this the Medallion architecture in our project.